So good morning everyone and welcome to this lecture. This is lecture number 6 in electrostatics and we are dealing with electric potential and electric field. In the previous lecture we had seen the formulae for electric potential, also electric field due to various types of charge distribution, whether it is a point charge or a ring or a uniformly charged conducting or non-conducting shell, a uniformly charged non-conducting shell, and so on. Do we remember this? Yes or no?
Yes, sir.
Now, we had done a few questions on this as well. We will do a couple of more questions before going any further. So this is the question we have done, brother of this question in electric field. This is the brother of the question in electric potential. Again, we'll assume that the potential at infinity is 0. Two concentric spherical shell of radius r1 and r2 having uniformly distributed charge q1 and q2. Find out the potential at point A, which is the center of the shells, at the surface of the smaller shell, point B, at the surface of the larger shell, C, at R smaller than R1, R between capital R1 and capital R2, and at distance more than R2. I'll give you 2 minutes to give me the answer for this one. So how are we supposed to find out the potential of the point A? This point A is nothing but the center of the two shells.
0, sir.
How will I get the potential of point A? Potential of point A would be due to two spheres, the green sphere and the blue sphere. How much will be the potential created by the green sphere? Potential of point A. Due to the green sphere, this point is inside the sphere, the center of the sphere, the center of the shell. The potential will be K Q1 by R1. Any point inside the shell, potential is same on the surface of the shell, whether it is the center of the shell or any point inside. So K Q1 by R1 is the potential due to the green shell. What will be the potential due to the blue shell? For the blue shell also, this point is inside. The potential will be same as on the surface of the shell, K Q2 by R2. That is your answer number 1. Now let us move on to the second point. At the surface of the smaller shell at the point B. The point B is on the smaller shell, which is inside the bigger shell. On that, we can understand and we can note down the potential of the point B on the surface of the smaller shell. It will be KQ1 by R1. Inside the bigger shell, it will be KQ2 by R2. So as you can see, potential of point A and point B are same. Let us move on to the point C. Potential of point C. Point C is outside the smaller shell, but on the surface of the bigger shell. It is outside the smaller shell. The distance is equal to R2 from the center of the shell. So the answer becomes K Q1 by R2 plus K Q2 by R2. Do we understand this?
Yes, sir.
Now, we move on to the next category. In the next category, we have to find out the potential at R, which is less than or equal to R1. So it is inside the first shell. Can you tell me the value for this one? The point is inside the first shell. What will be the potential of that point?
At point A, sir.
That is same as potential of point A. So I can write it as K Q1 by R1 plus K Q2 by R2. Now I move to the second point. R1 is less than or equal to R is less than or equal to R2. Can anyone tell me what will be the potential of this point, which is in between the two shells?
Smaller layer.
It is outside the smaller shell, but inside the bigger
KQ1,
shell.
KQ1 by small r plus KQ2 by r, sir.
K
R2, sir.
Q1 by small r plus K Q2 by R2. That is exactly correct. If R is greater than or equal to R2, which is outside both the two shells, what will be the answer in this case? K Q1 by R plus K Q2 by R. This is how we are supposed to find out any question which comes in this category. Do we understand this?
Yes, sir.
Well done, sir. Then this is same problem but given in a different way. So if you can solve this and give me the answer. Two concentric, hollow, non-conducting spheres of radius A and B. A is greater than B. Contains charges QA and QB respectively. Prove that. You have to find out the potential difference between the two spheres. And you will see that this is independent of charge on the outer sphere. That is what you will find out. First, you have to find out and you will have to remember this result. If the outer sphere is given some extra charge, will there be any change in the potential difference? This is a very important result that you will have to remember. Diagram is not a part of the question, but I will just give you the diagram so that you don't waste any time in understanding the question and concentrate more on to getting his answer. More important than getting this answer is you remember the result. You have already solved this question in the previous part. You just have to put the two parts together. I'll give you a minute to give me the answer for this one.
Sorry, sir. It is minus.
So what will you get? The potential difference between the two spheres, delta V, potential difference between the two spheres will come as KQB, inner sphere, into 1 by B minus 1 by A. Yes or no? I have done V of inner sphere minus outer sphere. Yes or no? You will get this or not? Yes or no? Yes or no?
Yes, sir.
What do we understand from this important discussion that if you have two concentric spherical shells, the potential difference between the two spherical shells does not depend on charge of the outer sphere. It only depends on charge of the inner shell or sphere. Do we understand this?
Yes, sir.
A very important thing to note down, a very important result to remember that has come in JEE many times. starting from the year 1980s. Have you noted this down, yes or no?
Yes, sir.
This is the next question. You might find it in your exam the next time around. A solid conducting sphere having a charge Q is surrounded by an uncharged conducting hollow spherical shell. Let the potential difference between the surface of the solid sphere and that of the outer shell is V. If the outer shell is now given a charge of minus 3Q, what is the new potential difference between the two surfaces?
D, sir.
B, 2V.
No, sir, it is D minus 2V.
Minus 2V.
V, sir, it is. Option A.
Option A. It does not depend on the charge on the outer shell or outer sphere. It only depends on charge of the inner shell or inner sphere. Do we understand this?
Yes, sir.
This is again one of the questions from JEE. And I think this came in one of the attempts for this year. Anyways, a charge Q is distributed over two concentric hollow spheres of radii small r and capital R. Capital R is more than small r, such that the surface densities are equal. What is the potential of the common center? What is the potential of the common center? You have 2 minutes to give me the answer. So how are we supposed to do this? Total charge is Q. That will be equal to Q1, charge on the inner shell, plus Q2. The surface charge density are equal. So sigma 1, the surface charge density of the first shell, will be equal to the surface charge density of the second shell. That means Q1 divided by 4 pi epsilon naught into small r square will be equal to Q2 divided by 4 pi epsilon naught into capital R square. From here, you should be able to get the values of Q1 and Q2. The value of Q1 inner shell will be coming how much? It will be coming as Q into small r square divided by capital R square plus small r square. The value of Q2 will be coming as Q into capital R square divided by capital R square plus small r square. Do you understand this?
Yes, sir.
Why? What had taken so much of time that you could not do it? The potential on the common center will be equal to K Q1 by small r plus K Q2 by capital R. Having written this, in fact, I did not have to write this. Once I get the value of Q1 and Q2, I must be able to tell you which is the correct option. The correct option is option D, and that is the answer that we were looking at. You have to be quick. JEE is all about speed. Do we understand this? Yes or no?
Yes, sir.
That takes us to the next question. Have you noted this down?
Yes, sir.
3 concentric metallic spheres. One is a sphere, the other two are shells, obviously. A, B, and C have radii A, B, C. A is greater than A, smaller than B, smaller than C. Diagram is given. And surface charge density are sigma, minus sigma and plus sigma. The value of VA and VB. VA is the potential on the inner shell. VB is the potential of the middle shell. You have to find out VA and VB. The time starts now. Option A is correct. How are you supposed to get? You don't have to calculate the potential of both the points. You can see looking at the options, this option is definitely wrong and this option is definitely wrong. They're dimensionally wrong. Do we understand this or see this? Yes or no?
Yes, sir.
The only two correct option may be option A and D. In option A, if you just calculate the simplest one, the potential of the point A, the inner sphere, the question is solved. You don't have to solve both the parts. Do we understand this?
Yes, sir.
You have to solve the question quickly. You don't have to solve both the parts. You just get the potential of point A. How do you get the potential of point A? It is K into QA by A plus QB by B plus QC by C. Yes or no?
Yes, sir.
You just have to find the value of QA. QA will be equal to sigma into 4 pi A square. Yes or no?
Yes, sir.
Charge on the sphere B shall be sigma into 4 pi B square. So it is A square by A plus B square by A, B square by B plus C square by C. Yes or no?
Yes, sir.
So it will be, one is, I think the option is wrong. Here it should be plus C, not minus C. So it will be A minus B plus C into sigma by epsilon naught. The option is marked wrong. Now the option is given wrong. Do we understand this? Yes or no?
Yes, sir.
That is the answer for this one. Everyone has understood this? Shall we move ahead? Yes or no?
Yes, sir.
We move on to the next heading. And the next heading is relation between delta V, potential difference, and electric field. Now this relation is very simple. I'll just tell you how do you get this relation. Force acting on any charge is Q multiplied by electric field E. Yes or no?
Yes, sir.
The small amount of work done by this force will be force Q into E dot with the displacement dr. Yes or no?
Yes, sir.
Change in potential energy will be negative of work done by this force. So it will be minus QE dot dr. Yes or no?
Yes, sir.
From here, you can find out the difference in energy or the change in energy. So the formula for change in energy, delta U, which is UB minus UA, it becomes integral from A to B with a negative sign. Integral of from A to B with a negative sign of Q into E dot dr. Yes or no? No or yes?
Yes, sir.
Or I can write UA minus UB. The difference in electrostatic potential energy will be nothing but integral from A to B Q into E dot dr. Every one of us understand this?
Yes, sir.
Or this has gone above our head saying bye bye. This is the relation between UA minus UB. Once you know the relation between UA minus UB, you can find out the potential difference VA minus VB. What will be the value of VA minus VB from the equation that we have just now written, it will be integral from a to b E dot dr. Yes or no?
Yes, sir.
So that means if you know the value of electric field, from there you should be able to calculate the potential difference between the 2 points. Yes or no?
Yes, sir.
You can also write this equation in this fashion: dv is minus E dot dr. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Have you noted this down?
Yes,
If
sir.
you- Okay. Noted this down, then we can move ahead. Now, if you have this electric field, if I have this electric field written in this form, Ex I hat plus Ey j hat plus Ez k hat, and your dr vector is written in this form, dx I hat plus dy j hat plus dz k hat. You can find out the potential difference between any 2 points, Va. Va minus Vb will be integral of Ex dx. You have to take the dot product. You remember that dot product?
Yes, sir.
Ey dy plus
Dy.
Ez dz. From this revolutionary formula, with this revolutionary formula, you can find out the potential difference between 2 points if you know the value of electric field. Yes or no? No or yes?
Yes, sir.
Give you 2 minutes to note this down. Then let us move ahead. I'll give you a question. So now I can give you a problem. Electric field is given as 2I plus 3J minus 4K. You are given 2 points. Point A is 1, 2, 3, and point B is 3, 1, 2. You have to find VA minus VB. You can find VA minus VB?
Yes, sir.
You have 2 minutes to give me the answer. So how are we supposed to do this? VA minus VB.
Sir, is the answer 5 volts?
I don't know. I'll have to calculate. 2, EX dx. EX here is 2. So it is 2 dx plus 3 dy minus 4 dz. And you can integrate this from 1 to 3. You can integrate this from 2 to 1, which is the value for y. You can integrate this from 3 to 2, which is the value for z. You can get your answer in this way. Do we understand this? Yes or no?
Yes, sir.
So this is as simple as it gets. I'll give you one more. Electric field is 2xi minus y square j plus 5k. The point is 1, 2, 1, and the point B is 3, minus 1, 2. You have to find the value of VA minus VB. I'll give you a minute to get the equations done. So how are we supposed to do this? VA minus VB will be integral of 2x dx varying from 1 to 3 minus integral of y square dy, this varying from 2 to minus 1 plus 5 integral of dz varying from 1 to 2. You can integrate this, you can put the values and understand. Yes or no? We have understood this, yes or no? We have understood this, yes or no?
Yes, sir.
The next heading that we are going to write is calculating E vector from V. Sometimes your potential V is given as a function. You have to calculate E from V. Now, how do I calculate your E from V? E ka x component is given by minus del V by del x. Do you understand the meaning of del V by del x? Partial derivative. I told you that, yes or no?
Yes, sir.
E ka y component is given by minus del V by del y. E ka z component is given as minus del V by del z. And therefore, I can write the electric field. I can write the electric field. I can write the electric field as like this. Do we understand this? Yes or no?
Yes, sir.
And if you want to find out the magnitude of electric field, the magnitude of electric field will be given as Ex square plus Ey square plus Ez square ka root. Do we understand this, or this has gone above our heads? Saying bye-bye.
Understood, sir.
Pakka, sir?
Yes.
I'll give you a minute to note this down. Have you noted this down?
No, sir.
Let me know once you are done. Then this is our next question, just to make you understand how to do this. If potential is given as a function like this, minus 5x plus 3y plus root 15z, find the magnitude of electric field at the point XYZ, at any point XYZ, to find out the electric field. I'll give you a minute to give me the answer. So how are we supposed to do this?
Sir, the answer is 7 volts.
The answer is 7 volts. You get the answer. You got the answer. I think that is correct. So basically, first of all, you have to get the value of this electric field in vector form, minus del V by del X. So you differentiate everything with respect to X partially. So you will get minus of minus 5I, that will be equal to 5I, minus 3J, minus root over 15K. Yes or no?
Yes, sir.
Then you have to find out the magnitude of this thing. It will be root over 5 square 25 plus 3 square 9 plus root over 15 square root over 49. You will get the answer as 5. Do we get this, everyone?
Sir, root 49 is 7.
Root 49 is 7. Do you understand this? Next one, do it fast. Give me the answer for electric field. Yes. So your electric field vector will be minus 2x I hat plus j hat. Yes or no? Sorry, minus j hat. Everyone
Yes.
got this answer?
Yes, sir.
So this is how you can find out electric field from potential. We have already seen how to find out potential difference from electric field. Everyone has understood this? Yes or no?
Yes, sir.
Let us move ahead and write some important notes. Important notes or important points about electric field and electric potential. Number 1. Absolute value of V or U. What do you mean by V or what do you mean by U?
V is potential and U.
Absolute value of V or U is not defined. What is U?
Change in potential.
Take a deep breath. I'll give you 5 minutes. Go back. Find out what is U. Give me the answer and then we will move ahead. So what is V and U?
Potential and electrostatic potential. U is electrostatic potential. Sir, U is electrostatic potential.
And V is?
Potential.
Take 5 minutes off.
Electric potential.
Go for a walk. Come back and give me the answer. So absolute value of V and U are not defined. Only delta V or delta U is defined. I don't know what is U and V and I'm not going to tell you that. If you don't remember it, forget about it. Only delta U and delta V is defined. Anyone remembers delta U, delta V? If you don't remember it, forget about it. It's no need. We don't have to worry so much about symbols and words. Only delta U and delta V is defined. And how it is defined? Delta U, UA minus UB. What is UA minus UB? If you don't understand it, just write UA minus UB. What will you get by understanding? Nothing. Just write UA minus UB. UA minus UB is integral of f dot dr from A to B, or you can write it as integral of Q E dot dr from A to B. Even if you don't remember what is this, remember it as U. The change in potential UA minus VA minus VB is integral of E dot dr from A to B. Absolute values of V and U are not defined, but what is defined is the change or the difference in the values of V and U. What is U? I don't know still. Doesn't make any difference to my life. We move ahead. VA minus VB. Now, remember, important points. If E electric field is 0, it does not imply V is equal to 0. But it implies delta V is equal to 0 or V remains constant. If electric field is 0, that does not mean, if electric field is 0, that does not mean that the potential is 0. It only means that the change in potential is 0 or potential is constant. I hope you are able to understand this. Are you able to understand this?
Yes, sir.
We don't understand what is U. We don't remember what is U, but we can remember what is this. Doesn't matter. U is U. A, B, C, D, S, T, U. U is U, sir. What, sir? We did it in standard KG1. U is U. S, T, U. U for umbrella. E is 0. That does not imply V is 0, but it implies the change in potential is 0. The next point. If V is 0, it does not imply, let me use common sign. It does not imply that electric field is 0. Potential is 0. That does not mean that the electric field is also 0. Potential can be 0 even if electric field is present. I hope you remember. I am not going to go back, because if I go back, you will not be able to answer it. I will just say something which I should not say. So let's not go into that. If V is 0, it does not imply that E is 0. Now, the next thing that we need to understand is, we have also given this formula, dV is minus E dot dr. That means it can be written as minus E का magnitude into dr का magnitude into cos theta. Into cos theta. Where theta is what? What is theta? Well, you ask so many questions. First, you asking U. S, T, U, V, W, X, Y, Z. U is U. Now, what is theta? Theta is the Greek alphabet.
Electric field and
Theta is the Greek alphabet, sir. And
angle between electric
we are studying English. Yes. What is theta? Apart from being a Greek alphabet.
And R vector, sir.
Thank God. See, God exists. I always, sometimes my faith gets disturbed. It gets shaken that God exists or not. But then I hear wonderful words from you students, and then that restores my faith that God exists. Theta, apart from being a Greek alphabet, is the angle between E vector and dr vector. Now, dV is minus E dot dr, that gives me a very good result. It implies that potential decreases. It implies that potential decreases in the direction of electric field. We have mentioned this before also. Now we are writing it again. Potential will decrease in the direction of electric field. This minus sign decreases in the direction of field. In the direction opposite to the field, potential will always increase. You can say this in a different way. Electric field is always moving from electric field, always go from a point of where to where?
High potential to low potentials.
From a point of high V to low V. High potential to low potential. High potential to low potential. Again, if cos theta is 0, no, that implies theta is 90 degrees. That implies dV is 0. That implies potential again remains constant. That means if you are moving perpendicular, if electric field is perpendicular to dr, dV becomes 0. Potential does not change in a direction perpendicular to the field. In a direction perpendicular to the field, your electric field is like this, and your displacement is like this, and your angle is 90 degrees. Potential does not change. Potential does not change. Potential remains constant. Potential remains constant. Potential remains constant. If your electric field lines are going like this, jug, 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 and you move perpendicular to the electric field, the potential of all these points A, B, C, D, and E will be same. The potentials of all these points P, Q, R, S, and T would be same. These points P, Q, R, S, T, or A, B, C, D, they have the same potential, and there is a surface which joins all these points. This surface, or this surface, or this, or this, or this, or this, or this is known as a equipotential surface. Equipotential surface. Equipotential surface is the surface of all those points which are at the same potential. I'll give you 2 minutes to note this down. We move ahead. What are equipotential surface? If all the points on the surface are having same potential. Then the surface joining all these points is known as the equipotential surface. We don't know what is U. It's STU. But still we know what is equipotential surface. See? Knowing U does not make any difference to our life. U is STU, U for umbrella. Umbrella Corporation was the name of a corporation in a movie. And I've forgotten the name of the movie. What is the name of the movie? Umbrella Corporation.
Static potential energy, sir.
Electrostatic potential energy is U, it's not umbrella. Okay. Great. Electrostatic potential energy is U, not Umbrella Corporation. Umbrella Corporation was in a movie, Hollywood movie, and I forgot the name of that movie. Let me Google it. It was one of my favorite movies. Resident Evil. It had a lot of parts, 5, 6, 7, 8. I saw it till 4, 5 parts. Umbrella Corporation was creating this virus. And this virus got out of the city. And then we had all sorts of Resident Evil, all sorts of mutants coming out of it. Umbrella Corporation. But U is not for umbrella. U is for electrostatic potential energy. Work done in moving a charge between any 2 points on an equipotential surface is 0 because there is no change in potential. The work done by the force is 0. Do we understand this? Or we have become umbrella corporation, virus mutants. Huh? We understand this? Equipotential surface will never cross each other. It is same as electric field lines because electric field lines never cross each other. Equipotential surface cannot cross each other. Do we understand this? Or this has gone above our head saying bye-bye?
Yes, sir.
Equipotential surface are always perpendicular to the lines of force. When we wrote the properties of electric lines of force, we wrote that electric lines of force are perpendicular to equipotential surface. You understand this? Or this is going above our head saying bye-bye?
We understood, sir.
Thank God. U is not for umbrella corporation. U is for electrostatic potential energy. Apart from STUV. For a point charge, this equipotential surface are spherical. For spherical charge, it is also spherical. For line charges, they are cylindrical. For planar charges or uniform electric field, these are planar. These are the diagrams for this. If the electric field lines are parallel and like this, constant electric field, equipotential surface are coplanar like this, plane. I just saw it. If this is a point charge or a spherical charge, equipotential surface are spherical. If it's a line charge, equipotential surface are cylindrical. Do we understand this, or this has gone above our heads? Saying bye-bye. I'll give you 2 minutes to note this down. Then you don't have to draw this, just see this. These are the equipotential surface drawn for 2 positive charges. You can see we had seen this diagram where we had drawn their electric field lines. Equipotential surface are perpendicular. That is what it is shown here. I hope you understand this. Equipotential surface are closely spaced where electric field intensity is large. So it is same as electric field lines. If electric field lines are large, electric field intensity is more. The number of equipotential surface would be more. Do we understand this? Yes or no?
Yes, sir.
Give you a minute to note this down. You don't have to draw the equipotential surface. It's just for your understanding that this is how it looks like. Then the next thing that you must understand is delta V, the difference or change in potential, does not depend on path. Do we remember this?
Yes, sir.
It does not depend on path. Whatever path you follow, let us say this is one equipotential surface. Let us say this is another equipotential surface. You may go from A to B in this path. You can go from A to B in this path. You can go straight like this. and you can go like this. No matter how you go, the change in potential will always be same, or the difference in potential will always be same. Yes or no?
Yes, sir.
If the value of electric field is E and the distance between these 2 points is D like this, which point will be at a higher potential, point A or point B? Which point will be at a higher potential, point A or point B?
It does not depend on point A, sir.
Point A. What will be the potential difference between point A and point B? VA minus VB. You can apply a bit of common sense. So I'm going to go in this blue path. When I go from this path, from A to C, let me call this point as C. I am moving in the direction of electric field. The change in potential will be E into D. When I move from C to B, there will not be any change in potential. So the potential difference between A and B will be same as potential difference between A and C. And the answer is E multiplied by D. Do we understand this?
Yes, sir.
What, sir? You should have given me the answer, sir. I'm disappointed, sir. But I have to let go of my disappointment, because if I get disappointed, I will lose a lot of time. And I don't have time to lose. So even if I'm disappointed, I have to move ahead in life. Now, we had seen the electric field due to an infinite line charge. And I told you we cannot find out the absolute potential, because absolute potential is not defined, because we cannot take any point whose potential is taken as infinity. But we can find out the potential difference between 2 points. This is point X and this is point Y. How are we going to find out the potential difference? We are going to find out electric field. The electric field between these 2 points, the value of electric field between these 2 points is 2k lambda by X. Yes or no? And I'm going to integrate this electric field, and I'm going to get the value of potential difference between these 2 points. That is what we had written. If you remember, in the points we had written the potential difference between the 2 points, and I'm again going to bring it to your notice. The potential difference between the 2 points, and the potential difference between these 2 points will be integral of this factor. X will be at a higher potential and Y will be at a lower potential. The value of Vx minus Vy is going to come how much? It's going to come from this integral, and I hope you can solve this integral. And the value of Vx minus Vy will come as 2k lambda natural log of R2 by R1. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
The third case I can take is the case of 2 infinite sheet, one having charge density plus sigma, the other one having charge density minus sigma. These 2 plates are separated by a distance of d. I told you, we discussed that the electric field between the 2 plates will be in this direction. Yes or no?
Yes, sir.
So which plate or which sheet will be at a higher potential, A or B?
At higher potential. A, sir.
A will be higher potential. Yes or no? Do we understand this? VA minus VB, and we had seen that the electric field between the 2 sheets is constant. It is sigma by epsilon naught. Yes or no?
Yes, sir.
So VA minus VB will become sigma by epsilon naught multiplied by D. Do we understand this?
Yes, sir.
Everyone understands this? I'll give you 2 minutes to note down these results. They are potential questions. If instead of two sheets, you have one single sheet of charge density sigma, point A will be at a higher potential, point B will be at a lower potential. The potential difference between the 2 points A and B would be sigma D by 2 epsilon naught. Yes or no?
Yes, sir.
I'll give you a minute to note this down. Also, you can note down one more point. The surface of any conductor is equipotential. Do we understand this?
Yes, sir.
All points inside a conductor are equipotential. Do we understand this?
Yes, sir.
Any surface inside a conductor is equipotential. Do we understand this?
Yes, sir.
So note this down as well. Then this is a question and I want the answer quickly. Some equipotential surfaces are shown at which point the value of electric field is greatest, A, B or C.
B, sir.
At point
B.
At point B, the electric field is greatest because equipotential surfaces are closer. Do we understand this? Yes or no?
Yes, sir.
Then the next question. Some equipotential surfaces are shown in the figure. What can you say about the magnitude and the direction of electric field? I'll give you 2 minutes to give me the answer. Magnitude is?
10, sir.
No, it is not 10. This is in centimeters. So this is 0.1.
Yes, sir.
Magnitude is not 10. So basically what you have to do first of all is you have to find the distance, the perpendicular distance between the two lines. This one, yes or no?
Yes, sir.
And how do I get the value of this one? I will have to draw a perpendicular from here to here. Yes or no?
Yes, sir.
And that will be the hypotenuse is 10 and this is 10 sine 30. Yes or 10 sine 37. Yes or no?
Yes, sir.
So that will be 6 centimeter. Yes or no?
Yes, sir.
The difference in potential is 60 volt divided by 60 centimeter is 0.6 meters. Yes or no?
Yes, sir.
So your electric field becomes 1000 volt per meter, not 10 volt per meter. We understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
How are the electric field lines going? They always go from a point of higher potential to a point of lower potential and they must be perpendicular. So they will be going like this. Do we understand this?
Yes, sir.
So this is the answer. The electric field lines move like this. Do we understand this? Yes or no?
Sir, answer is 100.
Yes, the answer is 100. Sorry, 1000. It's 100. We get this? Yes or no?
Yes, sir.
Answer for this one first. Yes, what is the answer?
Option B, sir.
Option B, sir. Do we understand this, sir?
Yes, sir.
This is the original question, sir. Some equipotential surface are shown in the figure. The magnitude and direction of electric field is. I will give you 1 minute to do this. So what is the answer for this one? You will have to find out the potential difference. Potential difference between these two lines is 10 volt. Yes or no? Yes or no? And then you will have to divide it by this. Sine of 30 is half. So 10 volt divided by half divided by 10 raised to the power minus 2. I think it will give you the answer as 200. And it will make an angle of 120 degree with the x-axis. Do we understand this? Yes or no? The electric field lines would be going like this. Everyone understands it? Yes or no? No or yes?
Yes, sir.
Okay, next one. Work done in moving a 20 coulomb charge from point A to point B for a distance of 0.2 meter is 2 joules. What is the potential difference between the 2 points? It is so difficult to do this. Work done by external force is charge multiplied by potential difference. So 2 divided by 20. The answer is 0.1 volt. I don't know what you are calculating for so long. Anyone understands this? We have forgotten the formula of work done and potential difference. Anyways, it was expected. So there is nothing that surprises me. This is the next question. A charge Q is revolving around a stationary charge capital Q in a circle of radius r. If the force between the charges is F, then the work done during the motion is how much? F into R, F into 2 pi R, F divided by 2 pi R. This is definitely 0 because this is not even of the same unit. Yes, which is the correct option? And the correct answer is 0. Force is perpendicular to the displacement. It is moving on an equipotential surface. So the work done by this force is 0. No problems here. Do we understand this?
Yes, sir.
Next one. There is an electric field E in the x direction. If the work done in moving a charge 0.2 coulomb through a distance of 2 meter along a line making an angle of 60 degree with the x-axis is 4 joule. Find the value of E. It is option D, 20 Newton per coulomb. How did you get this? So, your electric field is like this, E. Your electric field is in this direction, E. And I have to move it like this, 2 meters from A to B. You can write the work done as QE, which is the force, into the displacement, into the angle between this and this. You put the values, you get the answer, and you stay happy. We understand this?
Yes, sir.
This is the next question. An electric charge of 20 microcoulomb is situated at the origin of XY coordinate system. The potential difference between the points 5a, 0 and minus 3, 4a is how much? And the answer is 0. Potential at both the points are same. Yes or no?
Yes, sir.
Next one. A point charge Q moves from point A to D along the path A, B, C, D in a uniform electric field. If the coordinates of point A, B, C, and D are given, what is the work done by the electric field? This is a question from IIT-JEE. I'll give you 2 minutes to give me the answer. It is option A. You don't have to look at the path. You just have to go from A to A to D in whatever path. I will choose the easiest path. I will go from here to here and then I will go from here to here. Do we understand this? Yes or no?
Yes, sir.
I have to find out the work done from A to D by electrostatic force. That will be equal to Q. Work done is negative of work done is force multiplied by the displacement, and force will be in this direction, displacement in this direction, so it will be negative. Yes or no?
Yes, sir.
Force is Q into E. Just have to find out the displacement in the x direction and it will be equal to A. This is one way of doing it. It will be negative because we are moving it against the force. Yes or no?
Yes, sir.
Minus Q into E, E into A. Or you can find out the potential difference between point A and D. The potential difference between the points A and D. A is at a higher, A is lower potential, D is at a higher potential. Potential difference between A and D, VA minus VD is minus E into A. From that also you can do this. So you can do it in any number of ways that you feel like. Do we understand this?
Yes, sir.
Oh, this has gone above our head saying bye bye, bye bye, bye bye, bye bye. I'm going bye bye, bye bye.
We understood, sir.
Pakka?
Yes, sir.
Pakka na? Okay. Then we move on ahead and we write the next heading, self energy, electrostatic self energy, self energy. Number one is conducting sphere or conducting slash non conducting spherical shell. Why I have written these three things together? because no matter what I do, the charge for this will always come where?
On surface, sir.
The charge will always come on the surface, even if it is a conducting sphere or a conducting or a non-conducting shell. The charge on this sphere or this shell will come only on the outer surface. Yes or no? Now, this is not a point charge. It basically consists of a large number of point charges that has been brought from infinity and placed on this. To assemble this, some work has been done and that work is stored as energy. Since it is one body, we will call it the self energy. Actually, it is not the self energy, it is the interaction energy of all the small charges which are put here. Do we understand this? The self energy of this is given by this formula K Q square by 2R. Remember, when we talked about mutual energies, if the charges were like, it was positive. If the charges were unlike, it was negative. But self energy is always positive. It is always positive, whether it is a positive charge, you square it, it will be positive. Whether it's a negative charge, you square it, it will be positive. But when you talk about mutual energy, it is one positive and one negative, it becomes negative. Do we understand this?
Yes, sir.
You can also write it in this form, Q square by 8 pi epsilon naught R. The second one would be non-conducting. Non-conducting sphere. For a non-conducting sphere, energy will be stored inside. Charge will be coming inside as well as on the surface. Yes or no?
Yes, sir.
Energy for this one is 3 by 5 K Q square by R. This 3 by 5 times of K Q square by R. So you can write it in this way, 3 Q square by 20 pi epsilon naught R.
ఇక్కడ 20.0.
Have you noted this down?
Yes, sir.
This is the next question, sir. Two non-conducting but hollow uniformly charged spheres of radius R1 and R2 have charges Q1, and let me call this as minus Q2, just to make you understand the difference. One is having charge plus Q1, the other one is having charge minus Q2. You have to find the total energy of this system. Give you 2 minutes to give me the answer. So what is the total energy of this system?
It is 3 by 5 Q square.
K Q1 square by 2R1. This is the self energy of the first shell or sphere, hollow sphere, yes or no?
Yes.
Plus K Q2 square by 2R2. This is the self energy of the second shell. But apart from that, they also have mutual energy, yes or no?
Yes, sir.
To find the mutual energy, you find the potential and you multiply it by the charge. You find the potential at the center of any of the sphere
Minus.
and you multiply it by the charge of the other sphere. One is positive and the other is negative. The answer will be minus K Q1 Q2 by R. Do we understand this?
Yes, sir.
Everyone understands this?
Yes.
Two concentric spherical shell of radius r1 and r2. R2 is greater than r1. Have uniformly distributed charge q1 and q2. Find out the total energy of the system. I'll give you 2 minutes to do this. So what is the energy of the system? K q1 square by 2r1 plus k q2 square by 2r2, and then you find out the mutual energy. Yes or no? Find out the potential due to inner sphere on the outer sphere, or you find out the potential due to the outer sphere on the inner sphere. You will get k q1 q2 by r2. Yes or no? Do you understand this? Yes or no?
Yes, sir.
Everyone understands this? Everyone understands this?
Yes, sir.
We move on to the next thing, and that is known as energy density of the electric field. What do you mean by energy density of electric field? Now remember, wherever we have electric field, or for that matter gravitational field, or for that matter magnetic field, energy is stored in that space. Electrostatic potential energy, gravitational potential energy, magnetic energy is stored in that space. How much energy is stored in a given unit volume, small volume, is known as energy density. du by dv, small energy stored in small volume, is half into epsilon, where epsilon is the permittivity of the medium. If it is vacuum, I can write it as half epsilon naught into E square. This is the formula for vacuum. If it is any other medium, it becomes half epsilon into E square. Do we understand this?
Yes, sir.
Everyone understands this? Everyone understands this? So I can write small amount of energy du will be half epsilon naught E square into dV. To find out the total energy, you just need to integrate it. Everyone understands this? Yes,
Yes,
or no? Everyone has noted this down.
1 minute.
Then this is the next question, sir. Find out the energy stored in an imaginary cubical volume, in imaginary cube, whose side length is A, which is placed in front of a infinitely large non-conducting sheet of uniform charge density sigma. I'll give you 2 minutes to give me the answer. So how are we supposed to do this? How are we supposed to do this? Anyone?
Sir, we'll find total energy and then divide it by volume of cube.
You have to find out the volume stored in the cube, the energy stored in the cube. So you have to find out the value of u. U will be integral of half epsilon naught E square into dV. Half epsilon naught E square into dV. That's it. That is what you need to calculate. Energy will be equal to half epsilon naught electric field created by an infinite sheet is sigma by 2 epsilon naught. It is constant, yes or no? So this is squared multiplied by the integral of dV, volume. The volume of the cube is a cube, and that is the answer, my dear friends, that we are looking at. That is the answer that we are looking at. The final answer is this one. So the total energy I will get will be equal to sigma square a cube by 8 epsilon naught. I'll give you 1 minute to note this down. Moving ahead, we had seen this question where we had found out we have seen the energy, self-energy of a conducting sphere and a non-conducting sphere. Now, for a conducting sphere, the charge comes on the outer surface of the sphere. The electric field only exists outside. So, whatever energy is stored by this conducting sphere, by this conductor, it is not stored inside the conductor. Where it is stored?
Outside.
It is stored in the outer space. Whatever energy this is, whatever the self energy of this body is, it is actually energy which is stored outside. Energy stored outside, or q square by 8 pi epsilon naught r. This much energy is stored outside. For a non-conducting sphere, electric field exists inside also. Electric field exists outside also. Inside, outside, both sides. How much is the how much is the energy inside, how much is the energy outside? Remember, energy outside will be same as that one, kq square by 2r. And if you subtract the two energies, total energy minus outside energy, you will get the energy inside. I will give you the answer for energy inside by subtracting it. It is kq square by 10r. If you add these two energies, you will get your total energy, which is this one. Do we understand this, or this has gone above our head saying bye-bye? Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. We move on to the next heading, and the next heading is electrostatic pressure. We'll just write the heading and write down the value. Electrostatic pressure. Whenever we have a conductor, and we have the charge on that conductor creates electric field. The conductor creates electric field. Because of this electric field, the conductor experiences electrostatic force. The surface of the conductor experiences electrostatic force. Because of that electrostatic force, the conductor experiences electrostatic pressure, and that electrostatic pressure is given by this formula, sigma square by 2 epsilon naught, and this formula is again same as half epsilon naught into E square. So energy density and this pressure is actually having same formula and same value. Electrostatic pressure. Electrostatic pressure on the surface of a conductor is given by this formula. I'll give you a minute to note this down. Then you will write this small formula. We have not done surface tension. We have not done soap bubble. But what is a soap bubble? Let me just tell you very simply. A soap bubble. A soap bubble has it will be difficult for me to make it. Let me try my best. A soap bubble has a surface like this. Inside it is air, outside it is air, and in between this thing is very small. This is very thin. So you can call the radius of the soap bubble as R. Air inside, air outside. In between there is a layer of soap solution. Do we understand this?
Yes, sir.
Now, there is a difference in pressure between the inside surface and the outside surface. Pressure inside the soap bubble is always greater than the pressure outside. And P in minus P out is always equal to 4T by R, where T is the surface tension and R is the radius of the bubble. Now, if this soap bubble is charged, the relation that should exist between the surface charge so that the bubble remains in equilibrium is given by this formula. What you see on the right hand side is the pressure due to electrostatic pressure due to the charge on the soap bubble. Do we understand this? On the left hand side, whatever you have is the difference in pressure between the inside world and the outside world. You just remember this formula. If it comes, just put it. Do you understand this? I'll give you a minute to note this down. Noted down everything, beta?
Yes, sir.
Okay, then we will wind off this class here. In the next class, we will go ahead and see some properties of conductor, which is the next thing, and probably by next class we should be able to wind down your electrostatics. So Saturday your electrostatics will conclude, and on Sunday we will start with your capacitance and electric current, and see if you can, let's see how fast we can complete this. And so we'll move ahead with capacitance and electric current from Sunday onwards. In the next class, we'll try to wind up everything that is remaining of this particular thing. Let's see, we'll do that. Okay. On that note, I'll wind up this class today here. If you have any problems, let me know. I have sent you some sheets of the chapter that is coming up. You have already have the sheet for electric field and capacitance. Do you have the sheet for capacitance?
No, sir.
I'll send the sheet for capacitance and electric current as well. And I have sent you all the sheets, so you can start solving those sheets whatever extra time you get. So I'll see you in the next class. Take care. God bless you all. Bye bye.
Bye, sir. Have a good day.
Bye beta.